Good morning, class. This is your lecture number 7. It's a refraction of light. So today we will study about the numericals based on the lens formula and magnification. So later on I will tell you how you can draw the convex lens and concave lens, because many students were facing the problem while drawing the convex lens and concave lens, and at last I have solved the numerical problems, because many students told me that, sir, how we can do this question or that questions that were given to the worksheet. So that is at the last. Okay, so before going to the numericals, you have to keep some points to your mind, that is sign of magnification value. By sign of magnification, how we can find the nature of the lens. Okay, so from magnification we can find the size of the image, we can find the nature of the image, and we can also find the nature of the object, nature of the lens. Okay, so size of the image we can calculate by magnification, nature of the image we can calculate by the magnification, and nature of lens we can also calculate by the magnification. Now sign of magnification can be positive or it can be negative. Now if it is positive, then nature should be virtual and erect. I have already told you, if the sign of magnification is positive, then nature will be virtual and erect. Similarly, it is always virtual and erect if magnification is positive. Now if magnification is negative, then image is real and inverted. Okay, now the value of magnification can be less than 1. So if the sign of magnification is positive and the value is less than 1, then it is diminished. Okay, when value is less than 1, then it is diminished. I have already told you, this is the short recap of the last lecture. Okay, so if magnification is less than 1, then image is diminished. If magnification is 1, that it is of same size, then magnification is greater than 1, it will be enlarged. Okay, now the question is, if we have this data, how can I tell the nature of the lens? Okay, so if magnification is positive and the value is less than 1, it is concave lens. Okay, if the sign of magnification is positive and magnification value is greater than 1, it is convex lens. Okay, so this is the case when object is placed in front of convex lens between F and O. This is the case. Okay, and all these cases are for convex lens. So if magnification is positive and M is less than 1, then it is concave lens, otherwise it is convex lens. Okay, so you have to keep only one case in your mind, that when M is positive and it is less than 1, then it is concave, otherwise it is convex. So when magnification is positive and M is 1, this case is not possible. Okay, so no lens have magnification M and value 1. Okay, it will be the plain glass and no image will be formed. Okay, so we will not study this case. So numerical based on lens formula. So first numerical is the ratio of the position of image. So the ratio of the position of image and the position of object is 3:4. If the lens is convex of focal length 10 cm and the size of object is 5 cm, find the position of object, position of image, size of image, and nature of the image. Means we have to calculate u, v, h prime and nature. Okay, so what is given? Given the ratio v upon u is equals to 3/4. V is the position of image to the position of object is 3:4. So v upon u is equals to 3/4. Focal length is 10 cm. Now this is positive because the focal length of convex lens is positive. You already know that. We have to calculate h is 5 centimeter and h prime we have to calculate. Okay, so we know that from here we can calculate u is equals to 4v by 3. Now here I used minus sign because u is always negative. So this is the ratio. So from ratio we cannot find out what is the sign. So we have to mention the negative sign before u. Okay. So again from the Lenss formula we know that 1 upon f is equals to 1 upon v minus 1 upon u. So put all these values here. 1 upon v minus 1 upon u is minus 4v by 3. So this 3 will go up and minus will positive. So this is 1 upon v plus 3 upon v. So by calculating this we will get v is equals to 70 by 4 and v is 17.5 centimeter and v is positive. Okay. Now we know that u is equals to minus 4v by 3 from here. So putting the values we will get u is equals to minus 23.33. Now v is positive and u is negative. Now we can calculate the magnification. M is equals to v upon u. Now we know the value of v. We know that the value of u. So we know that the value of v. We know that the value of u. Put these values here. We will get the magnification is minus 0.75. And we also know that v upon u is also magnification. This is 3:4. So but we didn't know the sign of the magnification, but doing this math we get the sign of this is minus 3 by 4. Now minus sign means real and inverted image, and since the value is less than 1, so it is diminished. So the negative sign of magnification means image is real and inverted and the value is 0.5 which is less than 1, hence the image is diminished. Okay. Now let us calculate the h prime. We know that m is equals to h prime by h and the value of m is minus 0.75. Put these values here. We will get h prime is equals to minus 3.75. Now we can from here see that object was 5 centimeter and the image is 3.75 centimeter, means image is diminished. So the height of image is 3.75 below the principal axis. Why this is below the principal axis? Because the sign of h prime is negative. Okay. Now the next numerical is an object of height 8 centimeter is placed 20 centimeter in front of a concave lens of focal length 5 centimeter. What is the position, size and nature of the image? Clear? So given the object of height 8 centimeter is placed 20 centimeter in front of concave lens, means u is 20 centimeter. So u is 20 centimeter. Here I have placed negative sign because u is always negative. And since this is concave lens, we know that the concave lens, so wherever we place an object, its image will be always formed between f and o. So if focal length is 5 centimeter, the image should be formed at a distance less than 5 centimeter. Okay. Now focal length is 5 centimeter and we know that the focal length of concave lens is always negative. We have to calculate. H is 8 centimeter and h prime we have to calculate. Okay. So this is given and this we have to calculate. Now from the Lenss formula we know that 1 upon f is equals to 1 upon v minus 1 upon u. Put the values that is given to us. So from here 1 upon minus 5 is equals to 1 upon v plus 1 upon 20. So from here v is equals to minus 4 centimeter. Now u is minus 20 centimeter and v is minus 4 centimeter. As you can see, its sign is negative, means image is formed towards the left. Okay. And the value is 4 centimeter, which is less than 5. So our answer is correct. Now magnification is given by m is equals to v upon u. Now we know that v is minus 4 centimeter and u is minus 20 centimeter. So put these values here. So we get m is equals to plus 0.2. Now plus sign means image is virtual and erect, and since magnification is 0.2, it means it is less than 1, hence it is diminished. Okay, so positive sign of magnification means image is virtual and erect and the value is 0.2, which is less than 1, hence image is diminished. Okay, now here magnification is also given by h prime by h. Now we know that magnification is plus 0.2. So from here apply the formula and we get h prime is positive 1.6. Now the size of object was 8 centimeter and now the size of image is 1.6 centimeter, means it is diminished. So height of the image is 1.6 centimeter above the principal axis. Why we are saying above the principal axis? Because sign is positive. Okay, so this is how we do the question. This is very simple question. Okay, so third numerical is an object is placed at a distance of 20 centimeter in front of convex lens. Now here lens is convex and the distance position of object is 20 centimeter. What is the focal length of the lens should we use to get an image of double the size of object? Now we want the image of double size, means magnification is 2. So here given u is 20 centimeter and u sign of u is always negative, focal length we have to calculate. Magnification is given by m is equals to v upon u. Okay, and also we know that magnification is given by h prime by h. Now we know that magnification is twice, but it can be positive or it can be negative. Okay, so because it is convex lens and we know that there are two possible cases for convex lens. Magnification is positive for convex lens when object is placed between f and p if its value is greater than 1. Now value is greater than 1 and sign is positive, means image object is placed between f and o. Okay, and magnification can be negative 2, means the image can be real and inverted. So both cases are possible. If you recall the ray diagram of convex lens, you will get that both cases are possible. Okay, so we will solve this question for two cases. Okay, so case 1, when m is positive 2. So when m is positive 2, so put the value of m and put the value of u, we will get v is minus 40 centimeter. So we know u and we know v for this magnification. So apply the lens formula, which is 1 upon f is equals to 1 upon v minus 1 upon u. You will get f is equals to 40 centimeter. Okay, so this is simple math, that's why I'm fast forwarding it. Okay, so f is 40 centimeter. Now here you can see the sign of f is positive. Okay, so we know that the focal length of concave lens is positive. Now for case second, m is minus 2. So put the value in this formula, minus 2 is equals to v upon minus 20. So v is equals to plus 40. Okay, now from here lens formula, apply the lens formula, which is 1 upon f is equals to 1 upon v minus 1 upon u. So 1 upon f is equals to 1 upon plus 40 minus 1 upon minus 20. So this minus minus will go plus and we will get f is equals to 13.33 centimeter. So this is also positive for this lens. Okay, so we have two focal length. If we want twice in size and if we want virtual and erect image, so we have to take this formula, this focal length, the lens having focal length 40 centimeter. And if we want the double the size of image but it is real and inverted, then we will use the lens having focal length 13.33 centimeter. Okay, now some of the students were saying me that, sir, how can we draw a convex lens or a concave lens? So to draw a convex lens or concave lens, you need a scale, a compass, a pencil, or an eraser. So first you have to draw a line which will be our principal axis, like this, and point your compass anywhere in the line. Take a comparable distance. So point your compass anywhere in the line and draw an arc. Clear? Now again point your compass in opposite direction and draw an arc again. Okay, so you can erase the remaining part like this. So this is our convex lens. You can draw like this. So this is our convex lens. So this point is our 2f, which we call 2f1, and this point is our 2f2. Okay, so the line joining the vertices of this convex lens cuts the principal axis at this point, and this is our optical center. Now the half of the distance, so this distance is 5.5, so half of this will be our focus. Okay, now for concave lens, again you have to draw a line like this and point your compass anywhere in the line and draw an arc. Okay, again from opposite side you have to draw arc, but in this time you have draw an arc such that there is some distance in between this arc and that arc we will draw like this. Okay, so again draw a line parallel to the principal axis like this and like this, and erase the remaining part. So this is our concave lens. This is convex lens, and this is our concave lens. And this point where we have pointed our compass, this is 2f1, and this point is 2f2. Clear? So this is how we draw a convex lens and concave lens. Again, the midpoint this O is optical center, and half the distance between this will be our focus. This is f2 and this is f1, or we can say this is f1 and this is f2. Clear? So this is question number 23 from the worksheet. The refractive index of diamond is 2.42. What is the meaning of this statement in relation to the speed of light? Now what is given? Refractive index of diamond is 2.42. So this is absolute refractive index. This is absolute refractive index of diamond, because it is not given the refractive index of diamond with respect to this medium. So this is absolute refractive index. So absolute refractive index of diamond is equals to 2.42. Now we know that the formula for absolute refractive index, this is refractive index of diamond, so velocity of diamond will be in denominator, and absolute refractive index is always with respect to the speed of light, so that is c. Now the velocity of light in diamond will be c upon nd, means absolute refractive index of diamond. Now the velocity of light in diamond will be, the value of c is 3 into 10 to the power 8 meter per second divided by refractive index of diamond is 2.42. Clear? So it means that the velocity of light in diamond will be 1 upon 2.42 times the speed of light. Okay, so the meaning of this statement or this relation is the velocity of light will be 1 upon 2.42 times the speed of light in air. So the velocity of light in diamond will be 1 upon 2.42 times the speed of light in air. So the means speed is decreased whenever light goes to air to diamond. Its velocity will be 1 upon 2.42 times the speed of light in air, means 1 upon 2 means half. It is decreased by more than half times. Okay, so this is the meaning of this statement, means how much light is increased, how much light is decreased. So in this case 1 upon 42 times light decreased. Okay, so this is question number 24. The refractive index of crown glass is 1.52 and that of alcohol is 1.36. So the refractive index of crown glass is 1.52, means this is absolute refractive index of crown glass. So the refractive index of crown glass, we can say this is glass. So refractive index of crown glass is 1.52 and the refractive index of alcohol is equals to 1.36. Clear? So we have to calculate the refractive index of crown glass with respect to alcohol, means refractive index of crown glass with respect to alcohol. So we know that the formula, the refractive index of A with respect to B is equals to refractive index of A divided by refractive index of B. Okay, so using this formula, this will be refractive index of crown glass divided by refractive index of alcohol. So this is refractive index of crown glass is 1.52 divided by refractive index of alcohol is 1.36. So you can calculate this. Now the next is the refractive index of alcohol with respect to crown glass. The refractive index of alcohol with respect to crown glass will be 1 by this result, or we can say refractive index of alcohol divided by refractive index of crown glass. So this is refractive index of alcohol is 1.36 divided by refractive index of crown glass, this will be 1.52, and this is your answer. Now this is question number 25, which is we wish to obtain an erect image of an object using a convex lens of focal length 20 cm. What should be the range of the distance of the object from the lens? What is the nature of the image? Is the image larger or smaller than the object? And draw a ray diagram to show the image formation in this case. So this is very simple question. You can do it very easily. So what is given, that the focal length is 20 cm and lens is convex. So lens, this is solution, lens is equals to convex lens. Now remember all the cases when an object is placed in different position. Okay, so you know that when an object is placed between F and O, when object is placed between F and O, its image is always formed virtual and erect, and we also want erect image. This is the only case in convex lens. Okay, so when an object is placed between focus and optical center, its image is always formed virtual and erect. So this is the case. Okay, so what is the range of the distance of the object from the lens? So where should we place the object? It should be placed between F and O. So where is the O? O means 0 distance, 0. And where is f? F means 20 centimeter. So range will be, it should be less than 20, because we cannot place our object at focus. So it should be, range should be less than 20 but greater than 0. This should be our range. So it should be less than 0, sorry, greater than 0 but less than 20. This is the case, this one. When object is placed between F and O, its image will be formed virtual and erect. So what is the nature of image? Nature means it is virtual. Okay. Is the image larger or smaller? So we know that whenever an object placed F and O, its image is virtual and erect and diminished in size. No, sorry, enlarged. Enlarged in size. Okay. So we can draw, let this is our lens. This is optical center. This is 2f1. This is f1. This is f2 and this is 2f2. Okay. So let this is our object. First ray will go parallel to the principal axis. After refraction, it passes through focus. Clear? I am not using scale, but you have to draw the diagram using scale and pencil. Okay. So I am just giving the idea. So second ray will go through the optical center, and as you know, these two rays are diverging, so they will not meet in this side. So we have to extend these rays in opposite direction, like this and like that. So this will intersect at this point. So this will be our image. So now you can see it is erected. Erected means the image is above the principal axis, and since this image is formed by the extension of these two rays in opposite direction, that why it is virtual. So the nature is virtual and erect, and you know that you can see the object is this, the height of object is this, and height of image is this. So it is enlarged. Clear? So in question number 26, we have to prove n12 is equals to 1 upon n21. Means the refractive index of medium 1 with respect to 2 is equals to 1 upon refractive index of medium 2 with respect to 1. So this I have already proved in my lecture. So those who have not seen my lecture yet, please see my lecture. In my lecture I have already derived this relation. Okay, so I am not going to derive this again. Now in question number 27, it is given that refractive index of water is 4 upon 3 and refractive index of glass is 3 by 2. Again, these are absolute refractive indices. So we have to calculate the refractive index of glass with respect to water, and vice versa, means refractive index of water with respect to glass. So this is simple. Refractive index of glass divided by refractive index of water, and this is refractive index of water divided by refractive index of glass. Now you can put these values and you will get the answer. So this is question number 28 from worksheet, and I think many students are facing problem in solving this question. So here is the solution. So question is, the velocity of light in certain medium is 2 into 10 to the power 8 meter per second, and velocity of light in air is 3 into 10 to the power 8 meter per second. A ray of light traveling in air is incident on the interface of the air with the said medium at angle of 30 degree with the interface. So angle is 30 degree with interface. What is the value of sine of angle of refraction? So what is given? We have interface, this is medium air, and this is medium we don't know, so this is x, suppose. Okay, so light is traveling in medium air and it is incident at interface with an angle of 30 degree. Clear? So at the point of incidence we can draw a normal. This is our normal, and since the velocity of light in certain medium is less than the speed of light in air, so we can say this medium is denser, it will bend towards the normal. Okay, so let this is angle R. So what we have to calculate, what is the value of sine of angle of refraction? So we have to calculate sine of R. Now what is angle of incidence? Angle of incidence, angle I will be 90 degree minus this 30 degree, because this is the angle of, this is not the angle of incidence, because the angle of incidence is the angle between incident ray and normal, this. So if this is 30 and this is normal, so this should be 90 minus 30, so this is 60. So this is 60 degree, means angle I is equals to 60 degree. Okay, clear? So applying Snell's law, Snell's law, if we calculate the refractive index of medium X, it will be sine I by sine R. Okay, so we are calculating the refractive index of this medium, so angle of this medium will be in denominator. Okay, so that point you have to keep in mind. So whenever we are calculating the refractive index of any medium, its angle, the sine of its angle should be in denominator. Okay, now again we know that there is some relation between the velocity of light and refractive index. So again, if I calculate the refractive index of X with respect to the air in terms of velocity, so velocity of light in medium X will be in denominator, and numerator it will be velocity of light in air. So we know that velocity of light in air is 3 into 10 to the power 8 meter per second divided by 2 into 10 to the power 8 meter per second. So this is 3 by 2, or we can say 1.5. So now we know that the refractive index of medium X is equals to 1.5. So put this value in this equation, 1.5 is equals to sine I is 60 degree divided by sine of R. So we have to calculate sine R. This will be sine 60 is root 3 by 2. We know that sine of 60 degree is equals to root 3 by 2. Again remember the table. Okay, so this is sine R is equals to root 3 by 2 and divided by 1.5. Okay, so this is root 3 divided by 1.5 into 2, and this is root 3 by 3, and we can say this is 1 by root 3. So our answer is sine of angle of R is equals to 1 by root 3. Okay, so we can calculate it. So first you have to read the question carefully while solving the problem. Okay, first read down the question carefully and write down what is given first and what we have to calculate. Then recall all the information about that concept, like refractive index, how many formulas we have for refractive index, or we can apply these formula to calculate the values or to get the answer. So this is how we do the question. Okay, so from now I am not going to solve every problem that is given in the worksheet, because you have to do some hard work while solving the questions. Means if I will solve every question given in the worksheet, then you will say, oh, sir will do their question by their self, so why should I will do the these problems. Okay, so I will not going to solve every problem from the worksheet, but which I will find that it is difficult for the students, only this question I will solve. Okay, so you have to work hard and you have to do lots of problem related to refractive index or related to the lens formula and all. Okay, so Thank you class for today.